My name is James, and welcome to the guide to using StyleGAN3 with Gradient notebooks. Today, I'm going to walk you through how you can use StyleGAN3 to generate novel images using the pre-trained models available from NVIDIA Labs, and afterwards, how to generate your own StyleGAN3 image generator on Gradient notebooks. First thing we need to do is set up our notebook environment. So go to the Gradient console and log into your account or sign up if you don't have one. Sign up is easy, and we offer free access to GPUs for our free tier users, as well as better free GPUs for our paid users, and you should be able to follow along just fine. Once logged in, you can either create a new project or enter a previously created one. And once you've done so, go ahead and select Create a Notebook. This is the Create a Notebook page where we can customize our environment. Navigate to the bottom of the page and hit the Advanced Options toggle. This will open up our workspace and container settings. Set your workspace as https, just github.com/gradientai/StyleGAN3-notebooks, and set your Docker container to Maxime Durand /StyleGAN3:latest. Finally, scroll up to select the machine section and choose a GPU. I recommend you use a V100 or A100, as this is going to be a pretty computationally heavy project we're working on here. But given enough time and a suitably small batch size, any GPU should be capable of recreating what we're about to do. It's just going to take a really long time. Free tier users should also be careful. You may not get very high quality images on a model that's only trained for 6 hours on a weaker GPU, but that is the available time. So once these settings have been completed, we can spin up our notebook. Once your notebook is running, navigate to the IPYMB file StyleGAN3-notebook and run the first cell to clone 2 necessary GitHub repos to our new instance. And we need to do this in order to download our data set and actually do the StyleGAN3 training. So once this is done, navigate to your terminal on the left using the icon there and change your directory into StyleGAN v2 and go ahead and download our data set using the supplied bash script in StyleGAN, which you can do with bash download.sh AFHQ-dataset. Now this will quickly download, as it is less than a gigabyte and we have very fast internet. But it may take a moment to actually inflate all the image files. So have patience as this process is done. Okay, once this is done, navigate back to the IPython notebook. From here, we provided everything you will need to train or generate images, at least as far as the scope of this tutorial goes. The second repo we imported was StyleGAN3. StyleGAN3 performs optimally when training on data sets that are preloaded into a compressed zip file, and it provides a script called dataset_tool.py that will help do it for us. Run the second cell to run our dataset tool on our newly downloaded file, and it will output to a new directory data, the zip file AFHQ 256x2562.zip. Now that you've created your zip file, we're going to use this file to train our new model. But first, let's generate an image using one of the pre-trained models. In both my blog post and the StyleGAN3 repo, you will find a tutorial for how to generate an image using one of their pre-trained models that are stored online for our convenience. You can do so directly through the terminal once you have imported the repo StyleGAN3 and gotten the genimages.py file. Let's look at an image using their official AFHQ-v2 512 by 512 pixel image generator. And if you scroll to the bottom of the notebook, I have put in the command to run that. So all you need to do is run this cell and then navigate to the out directory to look at our hyper-realistic looking image of a cat. pretty impressive. You can see some of this artifacting down here, but otherwise looks almost identical to a real cat. So now that we've seen the final result, let's try and emulate their success on a smaller scale using our smaller AFHQ original data set, not the V2. So if you go to the third to last cell, the middle cell, you will find our training command. And our parameters, will set outdir as mods. This is a model. This is just a file for holding our models. Set the number of GPUs to 1. This is because we're using 1 GPU. Batch size to 24. If you're using a weaker GPU, I recommend you downsize this a little bit. Gamma to 8.2. We're using the data file. With the zip file we created, our configuration CFG is StyleGAN3-T, and we are taking a snapshot of the training every 10 iterations. You can change to snap, but all the other ones are required parameters. Snap is useful in our case because if we want to look at how the progress of training goes on over time, we can use these snapshots to see how the different quality of our models. The training process is very lengthy, so I have created a separate model with the training done over 24 hours for all of us to look at in here. And I've provided some images here of what those cats will look like. As you can see, the images we generate are not quite as high quality as those made by the official model from NVIDIA Labs. We still got some serious artifacting. Seed 0003 is the best example, I think, of this. It almost looks like it's in water. But with the computational and time restraints that we have, these are undoubtedly great images of cats that we've generated, and we can consider this a success. That's all for today. Now that you've learned how to run StyleGAN3 on Gradient notebooks, I'm looking forward to seeing all the projects that you all create. Feel free to tweet your work at us at Hello Paperspace on Twitter if you have made anything particularly cool. And also keep your eyes open in the coming months for follow-up tutorials for working with StyleGAN3 in our workflows and deployments contexts to see how you can really take your work to the next level with StyleGAN. Thank you for listening and have a great day.